Hello and welcome. Today we are building a calculator which help us explore some basic concepts. Stay tuned to see how we can transform a simple calculator program into a more optimized and enhanced version. Let's get started. First, we are going to take two numbers from user. In an earlier video, we have covered how to receive input from user. So if you haven't seen it, I recommend watching it first. Now let's ask the user to enter two numbers. To display inputs back to the user, print statement is invoked, which gives us output as 20 and 30. But what if user enters something unexpected, like text instead of a number? For example, if they enter first or second instead of number, in Python there will be no error because Python is dynamically typed language, meaning data type is determined at runtime. By default, values received from input function are of type string. To make our calculator work correctly, we need to convert this input to numbers. This process is called as data type conversion. We are converting string received from input function to number. Python has several built-in functions for this. For example, if we want to handle decimal values, we can use float function for conversion. Even with float, if user enters something other than number, Python will raise an error. To handle this, we need input validation. One common practice is to use try and except block within a while loop, which keeps prompting the user until they enter valid data. Here, try block attempts to convert input to number. If value error occurs, like user enter text, except block shows an error message. The while loop ensures user is prompted until they enter a valid number. Also, while with hard-coded true and break after receiving input will make num1 is a mandatory parameter to enter for user. This approach provides error handling and allows user another chance to enter correct data. Now I will copy paste same logic to second number. Now that we have two valid numbers, we will ask user to choose an operation like addition, subtraction, multiplication or division. For this, we can use a list to store valid operators. In Python, lists are defined using square brackets and can hold multiple items. Here is an example. A list in a Python is an ordered collection of atoms that can be of any data type. Lists are mutable, meaning their elements can be modified after creation. We will check if entered operator is in the list using a conditional statement. That is, if and else if statement. Python syntax is readable. Here is an example for this. If entered operator is in list, then execute this suit, else a print invalid operator. After receiving specific operator, we will perform corresponding operation. For that, we are using conditional statement. We are using if statement block. The if-else statement in Python allows you to check multiple conditions in sequence. If condition for if is false, it evaluates next condition in else if block. You can have multiple else if statement, and if none are true, else block will execute if that is present. To evaluate those conditions, we need comparison operators. These are arithmetic operators used in Python. Let's execute and test this code. Let's try to optimize and refine this code and try to learn more concept. Instead of having this if statement block, let's create function for each operations. Here is a syntax for function. Use keyword def to define function. After def, name the function followed by input parameters inside parentheses. After colon, you can start writing body for function. Once done, we will map each operator to corresponding function using one important data structure in Python, that is dictionary. Dictionary in Python is unordered collection of key value pairs. Each key is unique and it maps to a corresponding value which can be of any data type. Dictionaries are defined using curly braces with keys and values separated by colon, and each pair is separated by a comma. Here is an example. In this operation dictionary, key is operator character and value is corresponding function which is defined earlier. So we have mapped operator to operations. Let's see how we can access and find the value based on key from the operation. Take the variable name, that is operations, put key in square bracket. That is like this. It gives you value as a function, but it won't invoke the function. To invoke any function, we need to provide parenthesis. Inside parenthesis, you need to have input parameters. So this is a final syntax which in turn execute these functions. Let's remove this function with if statement block now because that is not needed. We can replace this function in operation dictionary with lambda functions to make code even more concise. Lambda functions are small anonymous functions in Python that are generally used for simple operations and can be written in one line. Here is how we can do it. To use lambda function, we can directly replace each function with lambda expression inside the operation dictionary. For that, you are using keyword lambda space input parameters separated by comma, colon and operation in one line here on num1 plus num2. Lambda functions immediately return the result of expression, making them ideal for single line operations. Instead of having repetitive code, here I'm adding one method for get number. There are multiple ways you can optimize your code. There is a need to understand the concept behind it.
That's it for today's video. If you found it helpful, give it a thumbs up and share your thoughts in the comments. Don't forget to subscribe and hit the bell icon. It helps us grow and ensures you don't miss updates. Your support works wonders with YouTube's algorithm. Thanks for watching.